Hi lads. Today I'm just going to run through question 8 and 9 just in case you found them difficult the last day. Then I think question 10 and 11 are kind of similar to question 9. Okay, so I'm just going to do question 8 and 9 off of page 527, okay? So page 527, question 8. Okay, so I'm just going to draw out the triangle there for you, okay? I have it drawn out there for you, so just reading the question then. The diagram below is a plan of a triangular shaped dormer window. All measurements are in meters. All line segments represented the frame of the window. Calculate the length of BD to the nearest centimetre. So this here is what we're trying to find in I, okay? So in this triangle here, I'm going to just, this is the hypotenuse of here. Okay, so then looking at it, I can't identify the opposite and the adjacent because I don't know either of these angles here, okay? So I need to find x here. I know the other two lengths, so I'm actually going to use Pythagoras' theorem to find that third length of that right angle triangle, okay? So I know that Pythagoras' theorem says that a squared is equal to b squared plus c squared. And I know that a squared is always going to be the hypotenuse. So 6 to be squared is equal to 5 to be squared plus c squared. Or x rather, sorry, I've labelled x in the diagram, so it would be x squared. So 6 squared then, 6 sixes is 36, is equal to 25 squared, or 25 squared, sorry, which is 25, plus x squared is just x squared. So then I need to get x on its own, so I'm going to take 25 off of both sides. So 36 take away 25 is 11. 25 take away 25 is 0, and we're left with x squared. So the square root of 11 then is equal to x. And if I stick the square root of 11 into my calculator, I should get 3.3166 meters is equal to x. However, the question asked to the nearest centimetre, so I have to multiply that by 100. It's going to be 331.66 centimetres is equal to x. Then it asks me to round it to near centimetre. So I'm going to get 332 centimetres is equal to x. Okay. Now my diagram is in meters, so I'm going to put in 3.32 in here to keep all in meters, okay? So that's part 1. So I use Pythagoras' theorem there. Part 2 then, calculate the measure of angle CDB to the nearest degree. So what angle are we talking about there? So if we go to C, we go down to D, and we go across to B then. So it's the angle that we make there. I'm just going to call that alpha for this one here. So again, we're talking about this triangle here, so we know now what angle we're talking about. So if I go across, I can identify my opposite and my adjacent. Okay, so I know from the sine rule that sine is equal to opposite over adjacent. Sorry, it's not sine rule, it's the sine, cos and tan. So sine is equal to opposite over hypotenuse, cos is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. So I'm going to use the one with hypotenuse in it and opposite. Okay, so I'm going to use sine. So sine alpha then, we don't know what it is, we're trying to find it. Opposite is 5, hypotenuse is 6. Alpha then is equal to sine inverse of 5 over 6. Alpha then, when we stick that into the calculator, we're getting 56.44. It asks the nearest degree, so alpha then is equal to 56 degrees. So So again, I'm just going to put it into my diagram there. Okay, so I use sine there. Could have used that even. Could have used cos to find it, and I could have used tan because I now know the 3 lengths. Okay, I just use sine out of handiness. Part 3 then. Calculate the length of timber required to make this frame. Allow for 5% wastage. So we want to make the frame, so we want to go enough wood to make all across here, up here, and down across here. Okay, we know this length and we know this length. So now we need to find this length and we need to find this length. So we're given 50 degrees. So if we come and mark off our hypotenuse, so directly opposite triangle. So H opposite the angle then, O and A for adjacent. So I'm going to find hypotenuse first. So I have the opposite and up for the hypotenuse. So I'm going to use sine, cos, or tan. Which one has opposite and hypotenuse in it? It's sine. So sine 50 is equal to the opposite, which is 5, over hypotenuse, which I'm going to call h. So multiply across my h to get rid of my fraction. H sine 50 is equal to 5. And then divide across by my sine 50 to get h on its own. So h then is equal to 5 over sine 50. H then, when I put that into my calculator, I should be getting 6.53 meters. Okay, so I go back up and I'm putting that in 6.53. Okay, so now I just have to find A. So you could use Pythagoras' theorem here. You could use number ones. I'm going to use tan. So there's a number of ways to find in this one. So it's tan 50 is equal to opposite, which is 5, over adjacent, which is A. So multiply across them by A. A tan 50 is equal to 5. A then divide across by tan 50 to get A and so on. A is equal to 5 over tan of 50. Put that into my calculator then. And A is equal to 4.2 meters. So if I go back up, then I know that this is now 4.2 m. Okay, so now I can find up by adding up all my lengths. So by adding up 4.2, 3.32, 6, and 6.53, I know all the lengths of timber that I need. Okay, so it's 6.53 plus 6 plus 4.2 plus 3.32. And when I add them all up, I should get a total of 20.05. So again, that's the amount of timber I need to do the frame, but I need to allow for 5% wastage. So I need to find 5% of this. So 20.05 multiplied by 5 over 100, and I get a total of 1.0025. So if I add that on to the timber then that I need, so 20.05 plus 1.0025, and that gives me, when I round it up, 21.05 meters is what I need. So hopefully that's okay, which is there then, lads. So that was question 8. So you might need to pause or go back. Okay, that was a long question. And the other question I'm going to look at is question 9. Okay, so page 527. Question 9. So I'm just going to take that down. Okay. So the question there just asks, what's the measure of the angle BAC? So part I, we are looking for the angle BAC. BAC. So we're looking for the unknown BAC. BAC. So we're looking for this angle here. So that we should all well know by now that no matter what kind of triangle that we're talking about, there'll always be 180 degrees in every triangle. So when we know the other two sides, we can just take them both away from 180. So if you have 180, take away 90, take away 60. Okay, so 180 take away 90 is 90. Take away 60 and we're left with 30 degrees. So that has to be 30 degrees, okay? Part 2 then. Question 9. Find the length of AB in third form. Okay, so we're trying to find this length here. Okay. So I'm going to, this is my right angle. So directly opposite my right angle is my hypotenuse. Opposite the angle I'm looking at, I'm going to use the 60 degrees. I could use the 30. Is opposite and my adjacent. So then I know that sine is equal to opposite over hypotenuse, cos is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. Okay. So I'm going to look at 60 and we're looking for the opposite and we have the adjacent. So we're looking for somewhere opposite and adjacent in it. So the only one of those three that has that is tan. So it's tan 60 is equal to opposite, which is x, over adjacent, which is 1. So 1 tan 60 then is equal to x. So if I put that into my calculator, I am getting root 3. So this here is root 3. Okay. And part 3 then, use Pythagoras' theorem to find AC. So we're trying to find h. So the hypotenuse is the one and so on. So a squared is equal to b squared plus c squared. So the hypotenuse then is h squared is equal to 1 to b squared plus root 3 to b squared. Okay, so h squared then, 1 by 1 is just 1 plus root 3 multiplied by root 3. A root multiplied by itself is just 3. Okay, so root 3 multiplied by root 3, we're left with just 3. H squared then is equal to 3 plus 1, which is 4. H is equal to square root of 4. And then H is equal to 2. Okay, so hopefully they were okay, lads. Alright, if you've any questions or you're stuck or anything like that, just let us know, okay? Alright, thanks.